Yo, welcome back to the channel. It's your boy Street Coder Nate, and today we're gonna review what we did a little bit in the last video and then take off all the way down the line to computer science and the different concepts. So in the last video, what did we cover? We covered pretty much like what is programming, and we covered it in a general sense. And so what I'm going to do over these next few videos is go into programming, more specifically the syntax, and explain what are we doing with the syntax so that you can use that syntax to communicate with a computer effectively. And so the syntax that I'm going to explain is JavaScript syntax, but you can apply these same concepts to C++, to C Sharp, to Java. I'm going to explain programming, functional programming, and a little bit of object-oriented programming because JavaScript gives us a little bit of that, but not in the traditional sense. So we won't go too deep into object-oriented programming just yet, but in these next few videos, we're going to talk about variables, data types, functions, conditionals, operators, and all of that stuff, and loops and stuff. We're gonna get all into it, and then basically the JavaScript object notation. The hope is that afterwards, after we get all of these concepts in and the syntax down, is that it's basically like we just learned that language, right? It's like I just spent time learning Spanish, so now I'm about to, after I got the Spanish language, now that you spend time learning that syntax, you can go communicate in Spanish. You can then go communicate in JavaScript to the computer. So we're gonna take some time over these next few videos just to get that syntax down, that understanding down, and then after we get those understanding, it's just like we're about to go practice it. We're about to go speak Spanish. We about to go travel the world or travel Latin America and speak Spanish. And then in our sense, we're gonna travel the internet, make different websites, and have some fun. So let's get into it. Okay, so in the last video, you seen something like this, and if you didn't see the last video, go check it out. I'm do a little link thing that goes somewhere up here. But okay, so in the last video, you saw me do something like and I was like HTML content. Or yep, you know what? I call it H1 content. Call it H1 content, and I said it equals document dot query selector, and then we passed in the H1 and close it off like that. Cool. So that's what you have seen in the last video. So I told you that this was declaring a variable. Okay, so how do I know that this is declaring a variable? Well, first, this keyword let allows me or tells me that that this line is declaring a variable. And pause. Let me pause first at this. So let me draw a line right here and then make this orange. That's one line. That's another line. And that's another line. I got 1, 2, 3. Okay, so what I just did here was pretty much create a page. This is a page, if you will, and this is the line number that we're on, and then this is the content for that line, the statement for that line. So the reason I wrote this like this is that I want to explain that when a a CPU reads your program, when the processor, the mind, the brain, when it reads your program, what it's doing is reading line by line. It's going line by, it's going line, line by line by line until it finishes the program. And so each line is a statement, is a command. Each line, you're telling the computer to do something. And so on line number 1, I'm saying let. And so if the computer reads a line in the first word on that line is let, const or var pertaining to JavaScript. Now, in other languages, you can say different things like int, char, and all different other things. But here in JavaScript, all we have to say is var, const, and let. And hear me out. These are called keywords, and there are more keywords. These are like reserved words that JavaScript used when they were defining the language, right? And so we got var, const, let. And so var, const, let basically allows us to create variables on the fly. And so the reason I use let here is because let is like a more new school var. And I say it's a more new school var because let tells me that I'm grabbing this HTML content and that the content may change throughout the program. Now, and I say that because there's this other word here, const, and const tells me that if I declare a variable with the word const in front of it, that this variable's data is not going to change over the period of the program. And then so var doesn't really tell me if the variable is going to change or if it isn't going to change. This was the original variable, how you declare variables. But as JavaScript got more sophisticated over the years, they moved down and said, okay, we want to know if it's going to be a consistent variable or is it going to be a variable that we're going to let change over time. And so you got your constant, you got your let. Okay. So therefore, on line number 1, what I'm doing, I'm declaring a variable. So we got our keywords, our 3 keywords right there. Keywords. Okay, what comes next? What comes next is the identifier. Right? Some people may call this your name. Identifier, I think. Some people may call this the name. It's the variable name, for real. It's what you call your variable. So whatever you're going to name your variable. And so typically you want to name your variable something that describes the data, right? And so if you look on the right-hand side of the assignment operator, so the assignment operator is going to assign the data that's on the right-hand side of it to the variable on the left-hand side of it. So if you look on the right-hand side of the assignment operator, you see we have a document.query selector, and we're selecting H1. In the last video, I told you that this is going to select the H1 tag. Therefore, I create a variable titled H1 content. Now, let me tell you some rules about creating variables. Typically, the regular syntax for creating variables is called like camel case syntax, and which allows you to say something. It's almost like the hashtag, where you'd be like hashtag like young, and you'll say this is like lowercase, but then you'll capitalize the life, like young life or something like that. That's pretty much what a variable is like, young life. It's called camel case, like that. If you have to say multiple names or multiple words, you don't have to put multiple words. You could say young, and you can set it equal to something. You can say y and set it equal to something. You can say y6 and equal to something. All right. So, but what you can't do. All right. So let me tell you what you can do. So you can start your variables with any with any letter. You can start your variable names with any letter, and you can start them with underscores. Those are the only things you can start them with in JavaScript and in most languages. Any letter. So any letter A through Z and A through Z, as well as underscores. After that, that's the first letter, right? After that, you can put you can typically put more underscores, any letters, and then numbers. That's what goes into variables like that. Now, you can't start a variable with something like this one right here. That's not a variable because it starts with the hashtag. But if I took the hashtag off, young life is a acceptable variable name, right? So this variable is describing the data that it's holding, right? And so HTML content is pointing to the data document.query selector h1. And we know that document.query selector, or we know that h1 tag lives in the index.html file. Therefore, this HTML content variable is actually not putting the data in itself. Rather, it's pointing to where that data lives. And so, and with that understanding, you have to. That's really how all data and variables work in computer science, for real. So hear me out. So like I said, on line 1, we're telling the computer to create us a variable. We're saying let h1 content equal document dot query query selector, and we get the h1. We tell the document that that's the first command. And what does now we tell the computer to do that. What does that do on the back end and the computer? Like in the background, what is happening when I say let h1 content equals document.query selector? Right. Well, let me break it down to you like this. Well, you kind of got to understand how really technology and life works, for real. Like in life, in the technology, what happens is there's data and there's processing of that data, and then there's data that comes out of the processing, and then there's more processing of that data, and then there's data that comes out of that, and then more processing. So what we're really doing is taking data, processing it, storing it somewhere, maybe taking some more data, processing it, extracting data, doing something to it, putting it back out. That's what we're doing all the time at our basic level as humans and as computers. We're just taking data, processing it, putting it back out. Okay, but the thing about us taking in all this data is that there's so much data. And so what we try to do as humans is just classify this data. We try to put names onto this data so that we can make sense of the data, so that we can put it in places that it reminds us of things, like a schema, if you will. And so we put names onto our data. And so the other video I was telling you about a memory. Let's say when I was talking about my basketball skill. Well, that data lives in the back of my head, right, or in my my long-term memory. Actually, let's scratch the basketball skill. Let's do something that everybody has failed to or has done before. So you ever forgot a word and it's just at the tip of your tongue, but you knew it, but you didn't know it? Guess where that word was at? It was in your long-term memory. And guess what was happening in the background? Your brain was searching through your hard drive. It was searching. It was like, I know this word, and then bingo, bango, boom, you know the word. Guess what happened? It found it in the hard drive and brought it to the RAM and stored it there. And now, every single time you needed to use that word in the next 5 to 10 minutes, guess what? You was able to pop that word back and forth, or back quick. That's literally how RAM works. You take it from the hard drive, that data. Remember the data here being, let's see, a word that I need to know. Take it from the hard drive. You have to go search the hard drive for it. You take that data from there and you put it into the RAM, and then you start processing that data, right? And so the data can be in forms of all different things. But in our sake, the data in this sake is let's say our data is a program. So we're thinking of a computer overall, and it goes and grabs a program from, let's say, the hard drive, because we have, and you think about humans, we have a bunch of programs in our long-term memory. I know how to play basketball, that's a program. I know how to code, that's a program. I know how to sleep, that's a program. I'm storing all these programs into my memory, and when I need to do those programs, my central processing unit goes into my long-term memory, brings that information, that data of all the instructions on how to do that process. It brings that to my short-term memory, my RAM, if you will, and then it starts to process it line by line. That's literally what's happening here with your programs, right? when you write your coding programs, when you write your code and you store it as files and you save it on your system, you just saved your code on a hard drive. Now, when someone runs your code and your JavaScript file, what's happening is they're gonna go grab that file from your hard drive and store it into what we call your RAM. Remember, that file lived on your hard drive. Let's call this your hard drive, and let's just call this your index.js file, and this is your hard drive, and we're gonna call this one the CPU. Got that coming out of it, so we know this is CPU. And then we got our RAM over here, which is just like a hard drive, but like a smaller one. And so remember, I was telling y'all about RAM and hard drive. If you ever wondering why your hard drive could always be like, well, Apple do 128, then 256, and then 512, and then a band, and then like 3, 4, 5 bands on terabytes and stuff like that, right? So why can't hard drives get that big? But then when you think about RAM, you always think about like a 4 gigabyte RAM, a 8 gigabyte RAM, and then like a 16 gigabyte RAM is real good, right? So basically that's saying like you like the hard drive in them terabytes, you can have a huge long-term memory. But typically when you're doing activities, you're not trying to remember every single thing that you know in your life, right? No, when you're doing activities, you just need to know that specific activity. So you only need a certain amount of space. I mean, and granted, given more space and an efficient CPU, you could be processing a lot of things, right? But so what our brains do is it comes here. What I say, we was looking for a word, right? Or what our CPU do. I already explained the brain, but what our CPU do is it comes here. It looks for our program file. It finds it in, or let's see, we call these like addresses, right? These are the addresses in our hard drive. We need to have addresses to where our data lives in our hard drive so that the CPU can go find it. It's like, okay, this index.js file, it lives at address 0 in my hard drive. I'm gonna go take it from address 0, bring it to address 0 in let's say it just says address 0 in the RAM. Remember, this is RAM, randomly allocated memory. And so it's going to take the index.js file from the long-term memory and put it into the short-term memory. And then that's what the CPU is doing right here, right? It's taking it and putting it here. Then the CPU begins to read this index.js file, index.js. So let's say our CPU was reading our index.js file, and our first line on our index.js file, let me clean this up a little bit for y'all. Our first line on our index.js file is us declaring a variable. So what does that really do behind the scenes with the CPU, and if we turn in terms of the brain and all of that, and the RAM and the memory, what is this really doing when I say let anything? So let me clean this up real quick. Got that? We got that. So we say let, and let's just, I'm about to create a quick variable name. I'm gonna call this number. So let number, and you know what? I'm just gonna call it num, so y'all could show y'all how we really get down in computer science. We always try to abbreviate things, man. When y'all get hired at these companies, y'all gonna see is ridiculous amounts of abbreviations. At Microsoft, we have a whole glossary online just to look up abbreviations. And honestly, every single time I look up an abbreviation, it's there. So like it's a bunch of them. All right. So you got let num, right? So let num. And let's just say num is going to equal 7. You know, we got joules, 7 joules. All right, cool. So let num equal 7. Cool. So what do we do? The CPU, it moved index.js from the hard drive to the RAM. We have went from the short-term memory to the long-term memory, or we have went from the long-term memory to the short-term memory. Now we are going to start processing these instructions, right? So if I was bringing back an action on read a book, I need to go bring back my long-term memory. If I'm not reading at that moment, I need to go I need to go figure out in my long-term memory how do I read, and then I need to come store that into my short-term memory. And then my brain, as I open the book and start processing and start looking at the words, my brain starts running that read these words program, and I start reading the words and understanding them and start storing the data into my brain and whatnot. That's exactly what's happening here. We brought back if this is the read the words program, we brought back the index.js. That's the program. We brought that from our long-term memory to our short-term memory. And now what our brain, the CPU, needs to do is start to process this file. It needs to start processing these actions. And so some programs depend upon data to happen. And in my case, if I'm reading, I'm depending upon the data from the book. I'm depending upon the words from the book for my program of read to happen. But some programs, you start them and they just automatically go. Let's say if you was about to go work out, like you don't need much data to work out. Let's say you going on a jog, you just put your shoes on and you go. You're not really waiting for like data to come into you for to go. Maybe you waiting on the weather or not, but if that's not the case, you don't really care. On conditional weather, you working out regardless, like then you're not really waiting on anything, and you could just start the program up. It's not waiting on any input, it's not waiting on any data, right? And so our index.js is one of those type of programs. It's not waiting on it's not waiting on any data. It's just a program that once it's loaded into memory, you could just start it right up. So our index.js, that's what we did. We just our CPU loads it into memory and just starts it right up. And so once it start up, it reads line by line the commands to do, right? And so the first line, it reads let num equal 7. So what is it doing when it says let num equal 7? Well, basically, remember, this is the memory over here. And so if I need to start using this part right here. This is the memory right here, this RAM. And so when I say let num equal 7, what I'm saying is declare me a variable num and set that variable equal to 7. And so in terms of this architecture, in terms of that architecture right here, what are we doing with, like, in terms of this architecture when we say let num equal 7, right? I moved the thing around, it moved me around. All right, let num equal 7. Oh wait, I don't think you got my let num equal 7 on it. Nope. Let me see. Hello. I didn't get my let num equal 7. Yeah, I think it disconnected. There we go. Sir, you getting money? How you feel? Okay, but in terms of that architecture, what's going to happen is we're going to take number. No, shoot, I gotta put this on. We're gonna take the program. Sorry, I try to do 3 things at once. My CPU trying to load multiple programs right now. Okay. Say you getting money, how you feel? All right. Here we go. So we got this num equals 7. So what is the program doing in terms of this architecture right here? What is the program doing? Well, or the CPU in the program and everything. Well, the CPU sees the let and it says, okay, I need to reserve some space in my memory because I know that I'm about to create some data that I need to save so I can use later, right? And you got to think about it. When you're having a conversation with people, you kind of like storing information as they're talking to you. And then when it's your turn, you're using that information so that you can talk to them. And so that's what we're doing here. We need to store that information for the short term. And the thing about it is we don't store all of the information. We just store important stuff. And as we're going through the conversation, we start going like, knocking, or we start processing that information even more. It's like, okay, you told me this, and then the story gets deeper, and then your brain starts processing and making different connections, and then maybe you even find out a solution for the person. Well, that's what's happening here. We're basically, when we say let num equal 7, we're saying, hey, I got some data that I need you to store for a little bit, because we're coming back to it and we're going to need to use that data later on. Whether that means adding it to something else, subtracting it, maybe even subtracting from itself and updating the data. There's something that we're going to need this data later on. So reserve me some space in your memory so that you can have this data there. And so when people talking to us, they kind of disrespectful because they're not really asking us to reserve that space. But when we say let num equal 7, we're pretty much asking the computer, hey, reserve that space in your memory for me, please. And so what is the memory? The memory is the RAM, y'all. The memory of the RAM. The RAM. So it's saying, let me reserve some space for a number, and the value of that space, the value that's going to be put into that space is 7, right? And so we need to know, like, once again, in the memory, we need to reserve some space. So what happens? The CPU says, it reads the let right there, and it says the let told me to reserve some space. Where is it going to reserve space at? It comes back over here in the memory. And let's say for right here, it reserves, like, let's say for all the data that it creates. So for all the different lets that as the CPU see let and all of that, it's going to put all that let stuff down here. This is where the data is going to go for this program. And so it saw its first let, and it said let num equals 7. So basically and let's call this address 1, address 2, and this is address 0. That's address 0 for the data, and then address 1 for data, address 2 for data. Overall though, this is all still the RAM. What the program just doing is just splitting up a specific part for the data. While maybe this part is for the instructions to run or something like that. And instructions, what are the instructions? The instructions are right here. So the program's gonna read the instructions, right? And then as it's reading the instructions, like, okay, I need to store this. I just saw a let 7, so I'm gonna come down here and create and store 7 right here. I know I'm storing on my memory for this conversation right now. I'm storing on my memory right here. But then after I store that 7, I'm gonna come back up here, run the next command that you tell me to do. Maybe that's like add 3 to that 7. So I'm gonna come back down here, update that to 10, right? But I mean, shoot, how could I add 3 to that 7? Like all we see right here is just a 7 in the bucket, or like we see a 7 in this list. In this RAM, like I said, 16 gigabytes, y'all. That is a lot of space. So, and even 4 gigabytes. So 1 gigabyte on some real. So like I put a 7 I put a 7 here. So what am I doing with that 7? Like, how can I know? How can I update that 7? It's a long list of information here. And so remember, I was telling y'all that computers see zeros and ones. So really what we saying, what's here is zeros and ones. Even the 7 is a 0 and 1. The computer understands it as a 7 though. And so I'm getting at a point here is that the computer only seeing zeros and ones here, like in all those spots, it's seeing zeros and ones. Now those zeros and ones mean something based on how it allocates the chunks and whatnot. But then let's say it comes down to this part right here, it's still seeing zeros and ones right here, and it needs to know like what data should I add 3 to? And it says add 3 to the 7, and it says, well, then it has to go through all of these and figure out which one is the 7, and then add 3 to it, and then store it back in the same location. Well, there's a way that the computer was like, a way for the computer to be like, you know what? There's a better way for me to remember remember the data that I'm storing. What if I create a name for the data that I'm storing? So not only are you telling me about this information, but now you're telling me about this memory, and I say this memory is Nate going to the beach. Nate going to the beach is what I'm gonna name this memory. And so now this memory, with all the different stuff that goes on in that memory, me going to the beach, now I can tie that back into just one name, which is that memory name, Nate going to the beach. And then now if I go up to somebody and say, let me tell you about me going to the beach, that memory is going to get pulled from my long term and into my short term, and I could just start processing all that information that happened at the beach. Right. Well, we need something similar as well for the 7. And so what we do is we also, inside the RAM, the computer also reserves some more space for names, right? And so this is for the variable names. And this is not how it's all really set up like this, but this is kind of like contextually like how we thinking about it. And so basically it says, all right, I see you said let num. So basically what it says is, all right, these are my variable names down here, variable names. And so it say let num. And so it says, all right, I'm going to create a variable named num and equal 7. And so it's going to point, well, when I say let num, basically this says num right here. This is going to be num, and num is going to point to a bucket. And so before you even put the 7 in there, num is just pointing to this bucket, and that bucket is like empty. And then now that we say 7, because we could say let num like this and just end it like that. You see, I put the semicolon. The semicolon is the close out, the end of a statement. Okay, so we say let num equal 7. We got num and let num equal 7. So now, or wait, we got let num, and that equals this bucket right here. Now I could say num equals 7. So what does that do? It comes to num, and it says num. Okay, you're a variable, so I know you're going to be pointing to to something. And so what are you pointing to? When it comes here, it says I'm pointing to this address right here inside of data. I'm pointing to address 0 inside of data. That's the bucket that I own and inside of data. So when people say they're putting data inside of a bucket, well, this is num, and it owns this bucket. And now anything you put in this bucket, num is always going to point to. And so we have this 7, and we're going to put 7 inside that bucket. And now num is always pointing to 7. So now if I wanted to go and increase num later on, I say num equals num plus 1. Well, what this does is the computer processes the right side of the assignment operator first. It processes the data first, and then it says, where do I store this data? And this is pretty much where we store the data. So process the data first. Process data first. And that's why we can say num plus 1 equals num, or num equals num plus 1, because we're going to do this side first. So what is num? Num is 7. We're going to add 1, so that's 8. Whereas we're going to store this 8, well, we're going to come to num. Where is num pointing to? Num, or what is num? Num is a variable. Okay, well, we know our variables live here in memory, right? Memory, this is RAM. We know our variables live here in memory, so let's go here. Num, what address you pointing to in data? Oh, I'm pointing to address 0 in data. Okay, well, we said we needed to update that to 8, and that's how your variables work in memory. And this is conceptually how all programs pretty much really work. But in JavaScript, once again, when we declare in our variables, we just need let, whatever our variable, we need let, const, or var. But I always tell the people I tutor is don't use var. Use the more new school ones, let and const. They just tell us more about the program. This allows for change and consistent data right here. So yeah, let and whatnot. So that's that. Honestly, so we really just got through. All right, yeah, we got through it. So you use let, you use const, you give a variable name, you use assignment operator, and you put some data in it, and you know how it all flows. Slow the video down. Try to go back over it a few times. Slow the video down. Try to go over it a few times and understand really what's happening, and try to think about it in terms of your own life for real, because this is really how our programming. This is really how our thinking works. And Steve Jobs said that programming teaches you how to think. Really, it's not teaching you how to think, it's teaching us how we think, how we work, not how to think. Because I mean, it will teach you how to do that as well, because you will learn that it's teaching you how we think. And once you learn how we think, you can start tweaking yourself to learn the way that you want to learn. And that's really cool. So here you go. You know how to declare variables in JavaScript, or you know how to declare variables, and specifically, you know how to declare variables in JavaScript. More specifically, you know what's going on in the behind the scenes in almost any programming language when we're declaring variables. Now, with this knowledge, we need to stake data into these variables, right? So we need to figure out what different types of data there are, right? Because there could be think about it. There's image data, there's text data, there's video data, there's all types of different data. And so we have these things called data types. And so we have these variables, and our variables store data, and there are different types of data. So in our next video, we're gonna hop into the different types of data that our variables can handle, that can hold. And like always, leave a like, leave a subscribe. I'm at 13 right now. I know it's going up. Line blowing up. It's going up though. So just leave a subscribe, follow me on the ground. You know how we doing. I'll see y'all in the next video. Peace.